Good evening, everyone. Today we are going to discuss about the dealing with materials data collection, analysis, and interpretation, assignment number 8. So let's proceed with assignment. Before that, we'll wait for some time. Let others also join. Let's give some 2 to 3 minutes break for others to join. Later we will start. Okay, let's start. So today we are going to discuss about the hypothesis testing. As we all know, like hypothesis testing is way of when we have a data, when we want to test whether the mean or standard deviation, whatever statistic it be, whether it is true or not. To test that, we can use this hypothesis testing. You can directly ask like instead of doing all this testing, if I have a value, population mean, and if I take a sample mean, and if they don't match, I can just easily reject, right? Like that you can ask. But the problem is we have to account for this sample size variation. For example, how much sample size is significant, or how much sample size we have to take to conduct to verify our hypothesis. So that one is an issue if we don't use any structured way or this rigorous framework as like what we are going to do now. So then, dealing with variability, we should know how much the standard deviation is. So here we account for the standard deviation to compare the results. If it is the variations within the standard deviation, then uh, it will be difficult to say whether there is an effect or not, or whether there is a variation in the result or not, and then error control. So we will be discussing two types of error in this particular discussion. So both type 1 error and type 2 error. So these errors are when actually especially the type 1 error is like incorrectly rejecting a true number hypothesis. If someone is tested positive for COVID, but we'll be rejecting the claim, like he is actually negative like that. So that is called type 1 error. Type 2 error is even if he is like tested negative. We are not failing to, so we will be failing to accept, prove that. So that is type 2 error. So we will be going through all these things, and then significance level, it's like it allows us to set how much a type 1 error we are willing to make. So that is significant level. So with all these things we can make our hypothesis testing, yeah, even more better. So we will discuss one by one, like how this hypothesis testing works and type of hypothesis, everything. And on in that way, we will be solving the respective problems for the assignment number 8. Okay, let's go with the further things. So type of hypothesis. So there are several type of hypothesis, but let's discuss the major and important hypothesis, like simple null hypothesis. By definition, it is a hypothesis that specifies a population parameter completely. So what we do it here is like we specify a value or a statistic, like it can be standard deviation or it can be a mean. Here, let's take an example. The average weight of an apple is 150 gram. That is like null hypothesis. We will specify a particular value for the null hypothesis, like 150 gram or 75 marks. Then what to say? Um, this much height, like 6.2 feet, 6.2 inch feet height. Like that, we will specify a value, and that is the average. Like that, we will specify in null hypothesis, simple null hypothesis. And then the alternate hypothesis for that would be like the average weight of the apple is not 150 gram. So it is simply like telling whatever this the value specified is not the actual value, like that. So here in this case, we don't have any ambiguity, or like we don't have any doubts. It's clear that if it is less than 150 grams, then it is clear rejection. More than 150 gram, it is a clear rejection. So means if the significance level, for example, if I specify like 0.05, then if it is not falling within that, or if the values whatever we are getting from our sample mean, the variation is less than the significance level. Less than means if you are specifying 0.05, it's a p-value. This the significance, the p-value whatever you are getting is less than 0.05, then it is like rejecting the null hypothesis. The null hypothesis here is that the average weight of the apple is 150 grams. So this is our population. From this, we will be taking a sample. So in that sample, we'll specify H naught. Sort of like some mean or standard deviation, and then HA. If the test statistic for the H naught, it is less than the significance level alpha for the one tail test. If it is a two tail test, make it like alpha by 2. So in that case, we reject H naught. So this is simple procedure for the simple null hypothesis. Okay, moving on. What is simple alternate hypothesis? So simple alternate hypothesis is the statement contradicts the null hypothesis, like what we have discussed before. If the average weight of the apple is not 150 grams, so that is like well, simple null hypothesis. So when we are failing to reject the when we are rejecting the null hypothesis, it is intuitive that you are accepting the alternate hypothesis. So yeah, here for example, the mean height of the students is not 65 inches. So that is an example for a simple alternate hypothesis. Here also we specify the directly specify particular value instead of specifying like plus or minus or equal. Sorry, within the range like that. Okay, which we can see it in the next one. One second. Okay. So next is composite null hypothesis. So what is composite null hypothesis? It specifies a range of possible parameters rather than a single value. It could not. It may include the sign equal to or less than or equal to, greater than or equal to. Like for example, the mean height of the product is less than or equal to 65 inches. This allows a range of values to be considered, not just a single specific value. So this is composite null hypothesis. And similar way, if we specify the range of value for the rejection, for example, if it's not equal to, means it will fall under the composite alternate hypothesis. So, and also simple alternate hypothesis we express in terms like HA or H1 as like a simple null hypothesis as H not. So now we know we know different types of hypothesis. Now we will see how what are the steps involved in hypothesis testing. So the steps like first we will state the hypothesis. So what is a null hypothesis? Like there is generally what we specify in null hypothesis like um, there is no effect because of the variation in any particular value. For example, um, uh, yeah, because of the since you all you guys are metallurgists, I can give you an example like addition of uh, carbon has an effect on the improvement in strength. So that is the alternate hypothesis. Null hypothesis is like addition of carbon has no effect on the strength of the steel. So that is a null hypothesis. And also, like when we specify null hypothesis, alternate hypothesis is also stated. Like as I specified, the addition of carbon has no effect on the um, has an effect on the strength, or addition of chromium has an effect on the corrosion resistance of the stainless steel. Like that, we will specify the alternate hypothesis. No effect means it will fall under the null hypothesis. So choose the significance level. So as we specified before, significance level is the um, error type 1 error, or otherwise we can call it like the amount of um, error you are willing to make, amount of mistake you are willing to make. That is a significance level. Generally, if its significance level is only 5%, some people even specify only 1%. So, if it falls within that, like we reject the null hypothesis, true null hypothesis. Especially we call this alpha as p-value. We take it as p-value of 0.05. If p-value falls less than 0.05 or 0.01, or in total it is for 0.08 to 0.025. Then we reject the type of null hypothesis. Yeah. For two tail, it is like both the sides. So it is alpha by 2. So we'll discuss those things in detail. Okay, so this is just choosing the significance level. That's the second step. So third step is like select the appropriate test. So this is very important because like whether we have to the data whatever we are saying sample mean whatever we are taking, should we do z test or should we do t test or chi-square test or for the categorical data? All those things we have to decide based on the type of data whatever we have got. The sorry. If the sample size is so large, like we can conduct the z test. So if the sample size is small, we generally quickly go for the t-test. And for if it is a categorical data, like if the results are in the categories, then we can use the chi-square test. So this is the selecting the appropriate testing. Okay. Then once we do all these things, for we will collect the sample data and prepare the data. So we get the data from the random from get random sample from the population, and then we will check for the test whether whether the distribution is normally distributed, or in that case we can go for the z test. So or otherwise we will go for the other different tests. So we will ensure whether the data meets the assumption of the user test. We can do this with the QQ plot, all those things. So then once we do the collection and preparation of the data, we calculate the test statistic. Now we conduct the test statistic by if it is z test, we just we just calculate the z value for the given mean value, and we compare the z value with the significance level, and we decide it. For t also the similar way we use, but we use the t test, so t score tables. F statistic uh, we use for validating our claim. And for categorical data, we use chi-square test statistic. And once we get that statistic value, we compare the p-value with the significance level, and we decide whether we are going to accept the null hypothesis or reject the null hypothesis. Generally, it is the question is, did we reject the hypothesis or failing to reject the hypothesis, null hypothesis? That is the general question. So then determining the critical range, as I specified, based on the one-tiled or two-tiled test, we specify the significance level values. Then make a decision, compare the test statistic to the critical value, and then critical value here we can also specify based on the significance level or p-value. We can go for the actual mean values. We can directly calculate the actual mean values from the significance level, and we can compare whether the value of the sample test data falls within the significance level or not. So comparing the test statistic, we either reject the null hypothesis. If there is no sufficient evidence, then we fail to reject the null hypothesis or accepting the alternative hypothesis. So this is the way completely we follow the hypothesis testing. So now we will go through the assignment question one by one. In between, we discuss about the type 1 and type 2 error and their associated problems. Okay. So first question, suppose you have ordered a certain kind of steel for which the manufacturer claims the strength of 150 MPa with a standard deviation of 5 MPa. Verify the claim. You want to test the hypothesis. It's not mu less than or equal to 150. What type of hypothesis is it? So, generally, when if you are an industry, you will know, you will be ordering a certain kind of material from a manufacturer, and they will be giving a data sheet, like specifying this is the data, this is the strength, this is the ductility at a given temperature, like that. They will be specifying along with the standard deviation, like 150 MPa plus or minus 5 MPa, like that. So what we do is like we take a sample out of it. If we are getting a lot, like lot means it can be like 100 sample or 1,000 or even 10,000 samples. We take a sample mean out of it, sample like 30 to 40 samples out of it. We do testing in our own testing labs, and we verify the verify like how much strength we are getting. So here the same case, what they are telling is like manufacturer claims 150 MPa plus or minus 5 MPa as the standard deviation. So we are here here the um, procurer or the person who is procuring is setting a hypothesis that H naught is less than or equal to 150. So once he specifies that the value what yes, one second. Okay. So here generally what we do is like if the value is greater than 150 MPa, means we consider it as a greater than or equal to 150 MPa, means we consider it as a positive sign for us because uh, the strength should not be less. It can be higher than the specified value, but it should not be lower than that. So hence we choose the null hypothesis to be choose the hypothesis of mu less than or equal to 150 to be a simple alternate hypothesis because our null hypothesis should be like mu greater than or equal to 150 MPa so that there is no variation as I expect no effect or no variation in the mechanical properties of the supplied quantities. To tell that we should have this statistic or this condition mu greater than or equal to 150 MPa. But in this case, we are having mu less than or equal to 150 MPa, which we can tell like a simple alternate hypothesis. Here you can tell like they have used this less than or equal to symbol, then it should be like a composite alternate or composite null hypothesis, right? Like that you can ask. But here, if you observe closely, they are specifying to only one particular value. They are not giving any range of values. They didn't specify like between 140 MPa to 150 MPa or like 145 MPa to 150 MPa. They have clearly stated if it is 150, then it is yeah, if it is 150, then right, the alternate hypothesis is sorry, the null hypothesis is true. If it is less than that, the alternate hypothesis is true. So that is what here the discussion is. So it is like if it is based on the single value. So we call it a simple alternate hypothesis here. Okay, moving on to the second question. There's a mass procured component of a vehicle that should weigh precisely 250 grams. So a vehicle should be 250 grams. I think 250 grams is nearly impossible for any vehicle. Assume that it is a small rover or something like that. Okay. The engineers take a sample of this component and want to know if they meet the specification of weight. Which of the following options is or correct in case of simple null and simple alternative hypothesis? So simple null hypothesis is like there is no variation in the weight, which means that H naught is mu is equal to 250 grams. So that is what the null hypothesis is. But there is an effect or there is a variation, which is the alternative hypothesis, right? So for that simple alternative hypothesis can be HA is mu not equal to 250 grams. So that is the alternate hypothesis. So correct answer is A. Give me a minute. Let me take water. Yeah, let's start the discussion again. So, coming to the third question, according to WHO, RT-PCR test can indicate whether the person is COVID positive or not. With a certain level of accuracy, imagine a person has been tested for COVID test and test report finds or infected. So type 1 error in this case can be given as. Okay, there are two possibilities here. The person is like not actually infected, but the report says the person is infected. That is false positive. And there are four possibilities here, I need to say. So one is like uh, person is actually infected and uh, the decision is like not rejected. So that is null hypothesis is not rejected. That's correct decision. And the person is not infected. The null hypothesis is rejected. So that is again a correct decision. This is called power of existing. So that is 1 minus beta. Correct decision is 1 minus alpha. Alpha is the significance level and beta is the uh, type. So probability type. So we'll discuss. These two are the correct questions. So now let's don't worry about it. So the actual problem is like when the person is negative, which means like actually he is not positive, but the report says he is positive. So that is false positive. So that is like the called type 1 error. Was possible. Here in this case also, if you read this problem carefully, actually the COVID test finds him infected, but actually he is not infected. So that is the case. So in this case, it is false positive. So correct answers. Moving on to the fourth question. The sample size of 20 is taken from the normal distribution of the known population standard deviation. So for normal distribution, from normal distribution, we are taking 20 samples. It has a population, it has the known population standard deviation. So the sample mean is 165, mu is equal to 165. If null hypothesis made for the population mean, mu is equal to 165. Again, standard hypothesis, that is mu is not equal to 165, that is statistical model. So since standard deviation, population standard deviation is known as it is normal distribution. Sample whatever is being taken from the lot is also should follow the standard normal distribution. So we can go with the standard normal distribution. If we don't know, then we can go with the t distribution with n minus 1 degrees of freedom. So that is here n is 20. So n minus 1 degrees of freedom is 20 degrees of freedom. Chi-square distribution can be taken if you are comparing the standard deviation. And with the statistical standard deviation, then you might have gone for the chi-square distribution for minus degrees. So here, this is the since the population is normal distribution, normal distributed, and we know the population is standard deviation, we can go with the standard normal distribution from the test statistics. And we can use the Z test. So that is what the meaning is. Okay. Moving on to the fifth question. Suppose for hypothesis testing, the significance level is given at 0.05. What is the probability of type 1 error or probability of rejecting the null hypothesis that it is true? Probability of rejecting a null hypothesis when it is true this type 1 error. So we can see in one time test the significance level is like 0.01 or 0.05. If the value, calculated value to fall within the significance level, less than the significance level, then it is like we are failing to reject the null hypothesis. That's a probability that we'll be failing to reject the null hypothesis. So, sorry, I mean, we are rejecting the null hypothesis when the p-value is less than alpha. But probability that it can be true is alpha itself. So, for example, a person who is like, we can take the previous cases into person, he might be uh, like he might be negative, but since the p-value whatever we have got is very less, it may fall under the positive category. So that is again like because we don't have much evidence, we are like rejecting the null hypothesis, but actually the phenomena might be true. Got it, right? Like for example, some phenomena like if I add like we take the steel as like stainless steel as an example. In stainless steel, I'm adding 10% chromium. 10% chromium is stainless steel. I'm adding 1% of extra chromium. Will it has an effect on the corrosion resistance? So actually, there might be an effect. Scientifically, there should be an effect because of the addition chromium. But our testing methods might have issues that it actually shows the lower p-value, so that we have to statistically we have to reject the null hypothesis that or statistically we have to reject the hypothesis that there is no effect. Okay, as an effect can be a null hypothesis, but but we have here, since we don't have the p value or no evidence, we will be rejecting that, saying that there is no effect. Okay. Moving on to the sixth question. So, sixth question is like a pharmaceutical company claims that its medicine has an active mean nucleate of 60 ppm, its standard deviation of 90 ppm. So, we have to test the hypothesis of H naught in mu equal to 65 against H A mu not equal to 63. 81 pills are tested and the medicine is considered to pass the quality test. Test only the mean active ingredient in medicine is more than 66.5 ppm and the probability of 5.9. Okay, here the mean active ingredient, mean of the population here is equal to 65 ppm. With standard deviation sigma is equal to 9 ppm. Um, and then they are telling like if the number of samples tested is 81 pills, and if the medicine is considered to pass the quality test, only mean active ingredient is more than 66.5 ppm. So that is the condition. For that, what we can do is like we will find the Z uh, is given by Z. Since the standard it has we know the populations have deviation and mean. We can use standard normal distribution statistic. For the standard normal distribution statistic, we have to standardize the value for that z is equal to x bar minus mu naught sigma by sigma by root m. So we know all these values. So 66.5 minus the mean value is 65. Yes, mean value is 65 and divided by sigma is 9 divided by 81. Here we can cancel this 9 into 81 and Z is 1.5. So Z, whatever you have got is like 1.5. So it's like less than or equal to, if we find the probability now, it will result in the left side of this 1.5. But actually, what we want is the right side, which is like more than 1.5 or more than the 66.5 ppm if it is true. So for that, what we do is like we calculate the uh, 1 minus p of z, 1 minus p, so that we will get this area, shaded area. So for that, the 1 minus p of 1.5, we see the Z table for 1.5, it is 0.9332. So 1 minus 0.9332 results in 0.0668. So this is the type of significance level. So it matches with our answer in the option B. So okay. So far we have discussed about the finding out of the probability of type 1, which is the significance level. Um, so now we will discuss about how to find the probability of type 2 error. So type 2 error is, as we discussed, it is failing to reject the hypothesis and null hypothesis is false. So probability of type 2 error can be given by beta, and we can control the type 1 error by setting the significance level. But here we cannot control the type 2 error. So type 2 error is uncontrolled type of error. And as we have discussed, power of the testing is nothing but probability of rejecting a false null hypothesis. Uh, Being it is false and we are rejecting is the false null hypothesis. That's called power of testing. That is 1 minus beta. So let's see what the example, uh, how the type 2 error looks and how to calculate the type 2 error. Okay, so let's go with an example. Here, Peter claims that average score of the final exam is less than 60%. He gathered a sample of 51 test papers and calculated the sample average to be 57%. So, here, actually, in the example, he is claiming that the average score is less than 60%. For that, he gathered a sample that is a null hypothesis, less than 60%. Um, then he gathered a sample of 21 test papers and he has actually calculated the mean sample mean of 57% as with the standard deviation of 12%. 12% is available. But once the final scores of all the people, everything came, the true mean, the true average mean score is 58%, which was the mean rate. So we have to find the gap, time to error. What is the probability of time to error? What is time to error? Failing to reject the hypothesis and null hypothesis. This was what we are here failing to reject. Our null hypothesis is mu greater than or equal to 60 is the null hypothesis. So failing to reject the null hypothesis is what? If the value is greater than 60 and or of course we have a significance level, we will adjust it to that. And if the value is greater than our critical value and if we are not rejecting, then it is called on show you. Based on significance level, if you are getting some value, if the value is greater than that, and if you are not rejecting that, then it will fall under that. Let's solve and find what is that value above which the uh, above which we might fail to reject. Then we will see what the next output will be probability. So this one second. So we have written the given value mu greater or equal to 60 is our null hypothesis which we have to reject. Mu less than or equal to 60 is the alternative hypothesis. So for that, the population mean we already know it is 60, and sample mean is from whatever he has calculated is 57. The number of samples taken is 51. Then standard deviation or the calculated sample mean for the sample is 12, and significant level specified is 0.01. So let's consider one tail test here, and we have to reject the null hypothesis if it is for the significance level of alpha equal to 0.0. So let's go ahead. Um, from the normal population table, for the significance level 0.01, to find the Z score, okay, Z score, it will be like minus 2.33. So this is a Z value. Actually, for adjusting to the mean, we have to know the value. For that, how we can calculate this? The critical value is given by mu population mean. That's plus uh, crit- critical is equal what we have calculated here into sigma by root. So it's here we are accounting for the variability and also we are accounting for the sample size. So this is what the advantage of the hypothesis testing, which we are discussing in the first slide. So mu at 60 plus critical value of t square 2.33 into sigma is 1 duration value. So the value which we have got from this is 56.08. Okay, so moving on. So we will plot it and let's see how it looks like. So for the for the population, it will look like this with mean of 60. If the value falls, it is more than that, you have to reject it. But actually, how much is the true mean value is 58. So 60 to 58. It's a true population mean. So if you are if you are if you are getting any value more than this 56.08, like the failing to reject, uh, then it is like follow the type to error. So this is the type error. So when it is false, but still their significant their value is high, p value is high, so they are failed to reject it. If they are like greater than 56.08. So this is the type 2 error. Let's standardize this type 2 error. Standardizing means we adjust it with c value and c. So for that, what we can do is we find the c value. This is but x bar minus by big sigma by root n. Here x bar is calculated with this 0.08 minus mu is actual minus 58 divided by 12 divided by root 51. So the z value whatever we have got is minus 1.14. So now if you analyze it, let's see the z value greater than 1.14 minus 1.14 is the type 2 error. So that's what we can do. Like for z values, we can find the probability of z is equal to 1.14 or like less than 1.14, which is given by the z captions, which is for 1.14 if we calculate the z value is 0.1274. Whatever you have calculated t towards the left. So we have to make it like 1 minus p of z less than 2.14 that minus 2.14 and we will be getting 87.28%. So this is the probability of type 2 error. I hope this should be clear. If you have any doubt, you can ask the question in the time to error. So next we will be going on with further problems. Okay. Moving on to the seventh question. In question 6, consider the following scenario. The mean active ingredient in the medicine is more than 66.5 ppm. The pills pass the quality test. Okay. Use the significance level of 0.05 to conclude whether the pills will pass the quality test based on the hypothesis. Okay, here actually they are telling mean active ingredient of medicine is 66.5. It's like that is more than the specified value. And the population mean can be taken as 66.5. And if it is so, what we are trying to see here is like we will calculate the statistics. In that case, our average sample average is also 66.5 and mean average is also 66.5. So when we calculate the value, it will fall like in the value in zero. Because the statistics will become zero. In that case, here the data, like whatever they have, the data does not support the claim that active ingredient is greater than 66.5. That is the answer what we can do because the value is taken to zero. Moving on to the eighth question. I hope the previous one should be clear since the mean of the population which the hypothesis is taking and mean of the sample, whatever you have calculated, both are same. If we calculate the statistic, it will become zero. So which means like the claim of greater than 65 will not be true. The data won't support it. That's a big. So moving on to the eighth question. If alpha denotes a significance level in the hypothesis test, then confidence level is defined as okay. So alpha is the significance level in hypothesis test. The confidence level is like 1 minus alpha. So alpha we have discussed before. It is like the probability also the probability. I mean, how much you are willing to take the risk, how much error you are willing to do. That is significant stuff. So which the confidence interval, if you specify 90% confidence interval means that then you are giving a margin of benefit of doubt of 5%. That is significant stuff. Here, the confidence interval by the confidence level is 1 minus 7. Okay. Okay. Moving on to the next question. The critical region is the region of distribution where null hypothesis is rejected. Actually, critical region means the region where you will be tending to reject the hypothesis. The, if the obtained value is greater than the critical value, then it will fall under the non-rejection region. If it is false, less than that, it will fall under the rejection. அப்பா சொல்லுங்கப்பா. ஏன்ப்பா சொல்லுங்கப்பா. ஓ! அப்படியா? எப்பப்பா? ஓ! சரி, சரி, சரி. ஓகேப்பா. ஓ! சரி, சரி, சரிப்பா. ஓகே. வருவேன் இன்னொரு டைம் ஆகும்ப்பா. இப்ப எப்படியும் நான் கிளம்புறதுக்கு இங்கேருந்து 12:30 ஆயிடும். ஆ வரத்துக்கு எனக்கு 1 ஹவர் ஆகும். அங்க ரீச் ஆகுறதுக்கு. வெயிட் பண்ண முடியும்னா வெயிட் பண்ணுங்கப்பா. நான் வந்துடுறேன். இது அந்த மிஷின் ரொம்ப வெயிட்டா இருக்காப்பா? சரி, சரி, சரி. சரி அப்புறம் நீங்க நம்ம சாப்பிட்டுட்டு வந்துக்கலாம்ல பாபு? ஆ. சரி ஓகேப்பா. அப்ப நீங்க வெயிட் பண்ணுங்கப்பா. நானே வந்துடுறேன்ப்பா. 12:15 அந்த மாதிரி கிளம்புறேன். கிளாஸ்ல இருக்கேன். முடிய போகுது. முடிச்சுட்டு நான் கிளம்புறேன். கிளம்பி வந்துட்டு அங்கே இருந்து சரி பார்த்துக்கலாம்ப்பா. 12:30க்கு அங்கே ரீச் ஆக முடியாதுப்பா. ஒன் ஓ கிளாக் 1:15 ஆகிடும்ப்பா நான் ரீச் ஆகிறதுக்கு. ஏன்னா இங்கேருந்து நான் கிளம்பி வரதுக்கு இங்கேருந்து 1 ஹவர் ஆகும்ப்பா. நான் எப்படி வந்து இல்லாட்டி நீங்க ஒன்று பண்ணுங்கப்பா. நீங்க அம்மாவை மட்டும் அழைச்சிட்டு வாங்க. நான் போய் எடுத்துட்டு வரேன். ஏன்னா முன்னாடியே சொல்லியிருந்தா வந்திருக்கலாம்ப்பா. இப்போ இல்ல இல்ல ஆல்ரெடி அதான் 1 ஓ கிளாக் வரைக்கும் வெயிட் பண்ண முடியும்னா நான் இங்கேருந்து இப்போ கிளம்பிடுறேன்ப்பா. சரி ஓகே. சரிப்பா. இல்லாட்டி இருங்க இருங்கப்பா. நான் வந்துடுறேன்ப்பா. பண்ணலாம்ப்பா. நான் இப்போ வீட்டுக்கு போறேன். வீட்டுக்கு போய் சாப்பாடு எடுத்துக்கிறேன். எடுத்துட்டு அங்க வந்துடுறேன். எங்க அம்மா சாப்பிடட்டும். சாப்பிட்டதுக்கு அப்புறம் நம்ம அங்க இருந்து கார் புக் பண்ணி வந்துடலாம். அந்த மாதிரி வரதான் பெஸ்ட். நான் இங்கேருந்து வரத்துக்கு ஒரு 1 ஹவர் ஆயிடுமா. நான் என்ன பண்ணணும்னா வீட்டுக்கு போய் பைக்கை போட்டுட்டு அதுக்கப்புறம் எங்க அக்கா ஏதாவது ரெடி பண்ணி வச்சிருக்கோம்ல அதை எடுத்துக்கிட்டு நான் அப்படியே கார்ல வந்துடுறேன். வந்துட்டு நான் உங்களை அழைச்சிட்டு திருப்பி நான் ரிட்டர்ன் வந்துடுவேன். அங்க வந்து நம்ம ம். சரிம்மா. இல்ல நிறைய திங்ஸ் இருக்குல்ல, எடுத்துட்டு வரது கஷ்டமா இருக்கும். ஆ. நீங்க பொறுமையா இருந்தீங்கன்னா நான் வந்து நீங்க உங்களை சாப்பாடுறதுக்கு வந்து நான் வந்தே கூப்பிட்டு வந்துருவேன். அப்படியா? சரிம்மா. பத்திரமா கூப்பிட்டு வந்துருவாங்களா அப்போ? ஒரு அவசரம். சரி சரி வா. நான் லேப்ல இருக்கேன். நான் இப்போ இங்கேருந்து கிளம்புனா எனக்கு 1 மணி நேரம் ஆகும் வரத்துக்கு. சொல்லியிருந்தா கூட காலையில கிளம்பி வந்து அழைச்சிட்டு வந்திருப்பேன். ம் சரி. சரிம்மா. சரி ஓகேம்மா. பார்ப்போம். பை.
ஆ இப்போ வந்து அம்பாள் ஹெல்த் கேர் அதாவது அம்பத்தூர்லேருந்து ட்ராப் வந்து வாங்க போகிறாங்க. ஆ அது வந்து சர்வீஸ் இருக்குங்களா மேடம்? விடுவாங்களா? இல்ல அம்பாள் ஹெல்த் கேர் அம்பத்தூர் போங்க. அம்பத்தூர்ல இருக்குது. ஆ ஐயப்பாக்கம். அம்பத்தூர் பக்கத்துல ஐயப்பாக்கம். ஆ ஆ ட்ராப் வந்து வடபழனில லலிதா அப்பார்ட்மெண்ட். வடபழனின்னு போட்டுக்கோங்க. லலிதா அப்பார்ட்மெண்ட்ஸ், கோபால் ஸ்ட்ரீட் வாங்கிக்கலாம். லலிதா அப்பார்ட்மெண்ட், கோபால் ஸ்ட்ரீட். ஆ ரெண்டு பேரும் ட்ராவல் பண்றாங்க. சின்ன சின்ன லக்கேஜஸ் தான் மேடம். எப்போ கிடைப்பாங்க டிரைவர் இப்போ? சரி. சரிங்க மேடம். எவ்வளோ பே பண்ணுறாங்க? சரிங்க சார். கொடுத்துடலாம். ஆனால் இப்போ எப்போ கிடைக்கும்? வெயிட்டிங் டைம் போடுவாங்களா? சப்போஸ் வந்துட்டு கொஞ்சம் ப்ளஸ் ஆர் மைனஸ் 10 to 10 minutes ஆச்சுன்னா? ஓகே. நான் அப்போ ஒரு 12:30க்கு புக் பண்ணிக்கோங்க மேடம். 12:30க்கு வர மாதிரி இருக்கும். சபரி நேமில் புக் பண்ணிடுறேன். இதே நம்பர் கொடுத்துருங்க. நான் பேசிக்கிறேன். இல்லை 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 வேண்டாம் மேடம். கொஞ்சம் டிரைவரோட டீட்டெயில் மட்டும் ஷேர் பண்ணுவாங்க. ஏன்னா அப்பா அம்மா வராங்க. உங்களுக்கு ஹெல்ப் பண்ணணும். அவங்க தனியாக எடுத்துகிட்டு வர முடியாது திங்ஸ் கொஞ்சம். அவங்க ஹாஸ்பிட்டல்லேருந்து வராங்க. அவங்கள்ட்ட டிரைவர்கிட்ட ரெக்வஸ்ட் பண்ணுவோம். நம்பர் என்ன கிடைக்கும்? நான் பேசிக்கிறேன். பிரச்சனை இல்லை. சரி. சரி. ஓகே. அப்பா நான் அதான் 12:30க்கு கேப் புக் பண்ணியிருக்கேன்ப்பா. அங்கேருந்து இங்கே வர மாதிரி. இப்போ உங்களுக்கு நான் அவர்கிட்ட பேசிடுறேன்ப்பா. கேப் டிரைவர்கிட்ட பேசிடுறேன். இவர் வந்து நம்ம இது மாதிரி தான், ஃபாஸ்ட்ராக்லேருந்து. ஸோ அதனால வந்து வெயிட் பண்ணுவாங்க. ஒரு 10 to 15 minutes வரைக்கும் கூட வெயிட் பண்ணுவாங்க. ஆம், அவங்க அவர்கிட்ட நான் பேசி திங்ஸ் எல்லாம் எடுத்துகிட்டு வர சொல்கிறதுக்கு ஹெல்ப் பண்ண சொல்கிறேன். ஸோ நீங்கள் அதான் 15 minutes நீங்கள் ஆகும்னு சொன்னீங்கல்லப்பா? சரி சரி அதான் பார்த்து எப்படியும் 12:30 கிட்ட தானேப்பா? 12. 12:30னா 10 minutes வெயிட் பண்ணுவாங்க. 10 to 15 minutes வெயிட் பண்ணுவாங்க. சரி நீங்க கேட்டு அப்டேட் பண்ணுங்க ப்ரோ. சரி ப்ரோ ஓகே. நீங்க கேட்டு அப்டேட். சரி நான் அப்போ அப்டேட் பண்ணிடுறேன் வாங்க. 12:40. சரி. சரி ப்ரோ ஓகே. சரி இப்போ புக்கிங் நான் குடுத்துருந்தேன். ஐயப்பாக்கம் வந்து வடபழனி ட்ராப்பு. இந்த நம்பர்ல இருக்கு. 12:30க்கு சொல்லியிருக்கு. இல்ல சார் நான் இப்போ ஒண்ணு புக் பண்ணியிருந்தேன் கேபு 12:30க்கு. அது வந்து 12:45க்கு ரீஷெட்யூல் பண்ணணும். ஒரு 15 மினிட்ஸ்ல டிலே ஆகுது. இல்ல இன்னும் டிரைவர் நான் அசைன் ஆகலைன்னு சார். சரி ஓகே. ஓகே சார். தேங்க்யூ. Okay, moving on to the 10th question. If one wants to test the hypothesis, that's not okay. They are doing the hypothesis testing for the standard deviation, the sample size, and the statistics you have. Okay, as we discussed before, the standard deviation follows chi-square distribution with n minus one vectors, which is like if you take the mean and the other statistic, they generally follow the uh, normal distribution, and if we have a very small number of sample means it will follow the distribution. But the standard deviation always follows the chi-square distribution with n minus one degrees of freedom. So we will use the statistic, chi-square distribution statistic with n minus one degrees of freedom. So yeah, now with that, we will with that, our assignment discussion was done. And if you have further questions, you can ask me. We can discuss. எத்தனை மணி பார்க்கலாம் மாதிரி இருக்கும்?